Hey guys, how are you? So this is the second tutorial on SAP2000, and in this tutorial I'll be showing you how you can draw this truss and apply these loads. Okay, so let me make clear that this is not an appropriate process for designing a truss, and this tutorial is not meant for teaching you how to design a truss, but this tutorial will be teaching you how you can draw grid lines using a different method as than that taught in the tutorial 1. Okay, so open your SAP program and go to File, New Model. Alright, and click on Grid Only. Okay, click on OK, and after that double click here at any grid point. Alternatively, what you can do is that you can right click and click on Edit Grid Data and click on Modify Source System, and you will land up in the same dialog box. Alright, so here is X grid data, and earlier we did grid data using the ordinates. Now we'll be doing the grid data using the spacing, right? Okay, so okay, let me show you the diagram. So this is grid A, this B, this C, D, and this grid E. So the spacing between grid A and grid B is 3 meter, right, in the X direction. Alright, so this is the X direction, this is the Y, and this is the Z direction. Okay, so in the X grid data, distance between A and B is how much? It's 3 meters. So we put this here 3, and the unit is meter. Okay, so after that distance between B and C grid is 2 meters, and distance between C and D grid is 2 meters, and D and E grid is 3 meters, and let's see, so D and E is 3 meters, and the distance between E and E grid is 0. That is the final distance right over here is 0. So you this 0 grid is mandatory. Okay, so you always have to put the final 0 while using spacing as a method of entering the grid data. So there is no grid in the Y direction, and there is a grid in the Z direction. Let me show you. Okay, so there is grid 1, and this is the second grid. The distance between these two grids, let us take 5 meter as an example. Okay, so we put 5 meter over here and 1 0, right, and delete the rest. Okay, and we click on OK. Okay, alright, so we are in the XY plane right over here, and we go to XG plane. So this is how it looks. Now we go to draw frame cable tendon, or we can click over here. Okay, so after that we draw a truss like this, like this, like this, like this, and this, this. So now you're stuck here. All you have to do is that click on the right mouse button. Okay, so and you can again begin. So there is yet another option, quick draw frame cable. If you click it, and all you need to do is that just click on the grid lines, and your diagram is ready. Okay, so this is the model of the truss, and yet another one you have to do. So you have to go there, and you have to join these. Okay, so right click. Okay, so we have oh, 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 I got this extra. Okay, so this is ready. Now I have to apply what kind of support. So hinge support here and roller support here. So I click here, and I go to assign, joint, restraints, and click on hinge, and click on apply. So hinge is ready. Click on here, click on roller, and click on apply, and click on OK. So now I have to apply the loads, right? So loads are 5 kilonewton, 10 kilonewton, and 5 kilonewton. Okay, so click on this joint and click on assign, and click on joint load, forces. force in the global z direction. So SAP takes upward z as positive. As the load is in the downward direction, we have to do is minus 5, right, kilonewton. Okay, so replace existing load, click on apply and click on OK. Now we select with this joint and click on assign, click on joint loads, forces, and click on 10 and apply, and click here and click on 5, apply, click OK. Okay, so we applied the loads. Now all we need to do is that run this model, right? Okay, we run it. Let's save, let's name it truss. Alright. Okay, so this is the deformed shape of the truss after the application of the load. As you can see, this is the zero force member and it doesn't undergo any kind of deformation. So if we start the animation, yeah, so you can see the roller support is moving while the hinge support is fixed. Okay, so we stop the animation and we go to display. So forces, stress, frame cable tendons, and click on axial force, show values, and click apply. So this is the axial force diagram. Alright, click OK, and so this is how you can see. If you just right click over this member, and you can see the maximum axial force is 20.59 kilonewton. And if you want to see axial force value at the different location, you can click on scroll for values and go on for looking for the value. Alright, so alternatively you can put the location right over here, and we're gonna see everything what these mean in our next lectures. So unit is kilonewton meter. Alright, so this is how you draw grid using spacing, and this is how you apply the joint loads. Hope this video was helpful. If it was, hit like and subscribe for more awesome videos. Thank you.